You've seen the stars. You've seen the galaxies. But that's only 5% of everything. 27% is dark matter, the invisible glue holding galaxies together. 68% is dark energy, the force pushing the universe apart faster every second. We've spent decades searching, billions of dollars, and still we don't know what they are. In this journey, I'm going to show you why dark energy exists, where it comes from, and why it's the greatest mystery in modern science. Dark matter, dark energy, they control everything you see, and they've been hiding in plain sight. Before we begin this journey of exploration, please hit the subscribe button to help support us in bringing you even higher quality content in the future. Look up at the night sky. What do you see? Stars, planets, galaxies, all the light you see. That is only 5% of the universe. The rest is invisible. It does not shine. It does not glow. It does not interact with light. And yet, it controls everything.
95% of the universe is invisible.
We call them dark matter and dark energy. Not because they are evil, but because we cannot see them. They are the invisible architects of the cosmos.
But if we can't see them, how do we know they exist?
By their gravity, by their influence. In the 1930s, Fritz Zwicky noticed that galaxies in clusters were moving too fast. There wasn't enough visible matter to hold them together. Something invisible was providing the gravity.
So, dark matter was discovered almost 100 years ago? And we still don't know what it is?
Exactly. That's the mystery. We know it's there. We can measure its effects, but we have never directly detected it. It is the ghost that haunts the universe.
And dark energy?
Dark energy is even stranger. It's not holding things together, it's pushing them apart. It's the force that is tearing the universe apart. Faster and faster, every second. Let's start with dark matter. It makes up about 27% of the universe. 5 times more abundant than all the visible matter, but it does not emit, absorb, or reflect light. It is perfectly dark.
Perfectly dark. Then how do we know it's there?
gravity. Imagine space-time as a rubber sheet. Normal matter creates dimples. Dark matter creates deeper, wider dimples. It bends light. It bends the paths of stars. It shapes the structure of the universe.
Those arcs? They're galaxies being stretched by something invisible?
This is gravitational lensing. The dark matter in the cluster bends space so much that light from galaxies behind it is magnified and distorted. We can map the dark matter by studying these distortions.
So we can't see it, but we can see its shadow. Its footprint, like tracking an invisible animal by its tracks in the snow.
Exactly, and the tracks are everywhere. Every galaxy, every cluster of galaxies is embedded in a halo of dark matter. It is the scaffolding upon which all visible structure is built. Without dark matter, galaxies would not hold together. They would fly apart. Without dark matter, the large-scale structure of the universe, the cosmic web, would not exist. Dark matter is the invisible skeleton of the cosmos.
It's beautiful and terrifying. Everything we see is just foam on the surface of this invisible ocean.
And yet, we have never seen a single particle of dark matter. We have built detectors deep underground, searching for the faintest interactions. We have built particle colliders, trying to create it. Nothing.
So we know it's there, but we can't catch it?
Not yet. But we are getting closer. New detectors are being built. New theories are being proposed. The search continues. And when we find it, it will revolutionize physics.
So dark matter is the invisible glue, the skeleton, the foundation. But you said there's something even stranger.
This is the bullet cluster. Two galaxy clusters collided. The visible matter, stars and gas, interacted, slowed down, and stayed in the middle. But the dark matter passed right through, forming two separate clouds on the sides.
The dark matter separated from the visible matter? It doesn't interact with itself either?
Exactly. Dark matter does not interact with itself. It does not interact with ordinary matter except through gravity. It is the ultimate introvert of the universe.
And yet, without it, nothing would hold together. The most aloof substance in the universe is also the most essential.
Now we come to dark energy. In 1998, two teams of astronomers were studying distant supernovae. They expected to see the universe expanding, but slowing down due to gravity. Instead, they found something shocking.
The supernovae were farther away than expected. That means
the expansion of the universe is not slowing down. It is speeding up. Something is pushing the universe apart, overcoming the pull of gravity. We call that something dark energy.
so dark energy is anti-gravity? It pushes instead of pulls?
Not exactly anti-gravity, but its effect is repulsive, and it makes up about 68% of the universe, more than dark matter, more than ordinary matter, more than everything else combined.
68%. 2/3 of the universe is something we cannot see, cannot touch, cannot detect except by its effect on the expansion of space. And we have no idea what it is.
What could it be? The simplest explanation is Einstein's cosmological constant, a property of empty space itself. Every cubic centimeter of vacuum contains a tiny amount of energy that pushes outward.
Einstein predicted this? Then why did he call it his greatest blunder?
Because when he first introduced it, it was to explain a static universe. Then Hubble discovered the universe is expanding, and Einstein abandoned the idea. He called it his greatest blunder. But now we know he was right the first time.
A blunder that wasn't a blunder. A constant that explains 68% of the universe.
But the cosmological constant has a problem. Its predicted value from quantum field theory is 10 to the power of 120 times larger than what we observe. The worst prediction in the history of physics. Something is missing.
So dark energy is the biggest mystery in physics. Bigger than dark matter. Bigger than quantum gravity. Bigger than anything.
Dark energy is not just a mystery, it is the future. The fate of the universe depends entirely on what it is. Is it constant? Is it changing? Will it tear everything apart?
Big Rip? What's that?
If dark energy is not constant but grows stronger over time, eventually it will overcome all forces. First, galaxies will be torn apart, then stars. Then atoms. In the final moment, the very fabric of space-time will be ripped apart.
And the other scenarios?
Big freeze. The universe expands forever, slowly cooling. Stars die out. Galaxies fade. Eventually, nothing remains but cold, empty space. And big crunch. Gravity wins. The universe collapses back into a singularity. Another Big Bang? Perhaps.
3 possible futures, and which one happens depends on what dark energy really is. A question we can't answer yet.
Dark matter and dark energy. Together, they make up 95% of the universe, and we know almost nothing about them. They are the greatest mystery in modern science.
But we know they're there. We know what they do. Isn't that enough? Do we need to know what they are?
Science is not just about what, it's about why. Understanding dark matter could reveal a new fundamental particle. Understanding dark energy could reveal a new law of physics. The answers will reshape our understanding of reality.
So, the search continues. New telescopes, new detectors, new theories. Because the 95% is not just empty space, it's the frontier, the place where our next great discoveries await. So after all this, we have to admit, we don't know what most of the universe is. We've been studying the stars for thousands of years, and we've only understood 5% of what's out there.
And that's humbling, isn't it? But it's also exciting. We've mapped the visible universe. Now we have to map the invisible. The frontier is not beyond us. It's all around us. It's in every cubic centimeter of empty space.
So the greatest discoveries of our time are not in the distant stars. They're in the empty space between them.
Every time we thought we understood the universe, it surprised us. We thought the Earth was the center. We were wrong. We thought the sun was the center. We were wrong. We thought the universe was static. We were wrong. Now we think we know what matter is, but 95% of it is invisible.
The universe keeps reminding us, you are not the center. You are not even made of most of it. You are a tiny, beautiful exception.
Exactly. And that's what makes us special. We are the 5% that became conscious, that learn to ask questions, that learn to look at the 95% and say, we don't know what you are, but we will find out. Dark matter and dark energy, the invisible majority, they are not obstacles. They are invitations to explore, to question, to discover. The 95% is not empty. It is full of possibility.
Thank you, Kaler, for showing me that the invisible is not nothing. It's just waiting to be understood.
That's what science is, my boy. Turning the invisible into the visible. One question at a time.
The invisible revealed.
The universe is not what it seems. Most of it is hidden, but we are learning. Slowly, patiently, we are pulling back the veil, and what we find will change everything.